today I will be speaking about clean architecture concepts because it's a topic that kind of took my attention, and I wanted to look into it and do a presentation to you all. So if you don't know it, it will be a very good opportunity for you to kind of get an idea of what clean architecture is. So as Mackenzie said, my name is Vivian. I am a lead volunteer for Women Who Code Mobile. And I also work as a lead mobile developer at Impedimed, which is a company that is based on creating medical devices. And I'm also doing in parallel PhD on software engineering, mostly focused on smart cities and code quality for software. So here's an overview about what we're going to see today. First, I will talk a little bit in general about software architectures and what they are. And then we're going to focus more on clean architecture and how it's layered and all its layers in detail. And then I'm going to give a few small examples of how you can structure your project. And then I'm going to focus on a specific one to give you an example of how the flow goes within the code. And at the end, of course, I have all the references and the repositories that I have based this presentation on. And you will have the ability at the end to ask any questions if you would like to. And if the time runs up, you can continue the conversation, or you can ask me anything you want on Women Who Code Slack channel. So let's get started. First, let's start by talking a little bit about what is software architecture. So software architecture is basically a very high level representation of a system. It kind of gives us the structure of that system, and it's usually divided into layers, and these layers have components in them. So the layers are synthesized by components, and of course these components communicate with each other. They have relationships, and these relationships are also can be represented through a software architecture. So we want to aim into building architectures that are that will create simple and understandable systems. So we get the benefit that new members of our team or other members of our team that want to contribute to our code can do it more easily and can adapt very quickly to that. Also, we want to create, since features need to be added constantly and requirements change very frequently, we need to create systems that are flexible and expandable to new changes and new features. And also, we want to create an architecture that will bring an integrity and quality to our product. So focusing on the testability of our system will bring a lot of quality to it, and will also bring maintainability, which will lead to lower cost in terms of timing and money, because the system will be more maintainable and thus being more less costly to do changes or finding bugs. Today we will be talking about specifically about clean architecture, which is and we will see how all the features, the quality attributes that I mentioned before can be found in this architecture. So clean architecture is user-centric, which means that it focuses mostly on use cases and what the user actually wants. It focuses on what is the immediate business value. So what does the business want right now? What does it need right now? And it also minimizes the cost since it creates more, focuses on testability and creates more testable systems. And that that concludes that we have less technical debt. Clean architecture is also loosely coupled, which means that components inside the architecture have very few dependencies between them. So it creates a less coupled system, and it's also framework and UI independent. So we want, with this architecture, to create as few dependencies as possible. Here is an overview of the clean architecture. So it can be represented as a sphere or as a circle. And in the center, we can find the enterprise business rules. And then in the pink layer, let's say, we can find the application business rules. And then in the outer layer, we have interface adapters. And then in the last layer, which is the outer layer, we can find frameworks and drivers. One thing that we have to keep in mind when designing clean architecture is the dependency rule, which is all dependencies must point inwards, which means that here, as we saw, the enterprise business rules know nothing about all the other layers, and frameworks and drivers, which is the outer layer, knows everything about the inner layers. Now let's go ahead and explain what each layer actually represents. So we have the enterprise business rules, which is, as we saw, the most center part of the layers, and it actually constitutes the domain logic. It's a very abstract and high-level representation of our entities, and it's basically our model, which rarely change. And there you will find, for example, classes that are called, for example, product or user or administrator and stuff like that. Next, we have the application business rules. And in this layer, we define all the use cases and what the business actually wants and what the user wants to do with our application. So this layer is responsible for the coordination of data. So it has a dependency with the previous layer. It knows stuff about the previous layer, but knows nothing about the other two. So getting and coordinating that data from the inner layer, from the domain logic, will help move on the data to the rest of the layers. And next we have the interface adapters, which in this layer is responsible for converting the data, presenting the data, and controlling the data. So any data that comes from the application business rules, from the use cases, here it's been handled and it's being transformed and ready to be presented. And then we have the frameworks and drivers, where this layer is responsible for any external resources. And then there you can find the user interface, any tools, any third-party libraries, devices, etc. Okay, so now I will give you some few examples of how you can structure your projects. These examples are based on already existing repositories and examples that other people have done, and I found very good examples. So I will have all the links in the slides at the end. So here we have an example of an Android application written in Java, and you can layer the application into modules in this approach. So we have, as you can see here, the domain module, where here it's where all the business logic is being contained. So there you will find the model plus the use cases. This can be a pure Java module, and it's basically the module that it's in between the data module and the application module, where we will see. Next, we have the data module, where here we have the implementation of the repository. And actually, in this example, they follow the repository pattern, which basically it's an interface of the repository, and it belongs to the domain module. And then in the data module, we go ahead and implement that repository, which helps us actually get the data from the domain module to the data module. And also here in this module, every handling that has to do with cloud, retrieving data from the cloud or storing it to the memory, the third preferences, it can be found here. And then this module also has some, it's not a pure Java module, it's a module that can have Android dependencies. And then we have the app module, or you can call it presentation module, where you will find all the activities, all the fragments, all the animation, and you can also apply their patterns such as MVC, MVP, or MVVM. Also, since we talked about testability, this structure can help us test each module separately without dependencies. So we can test the domain module by applying JUnit and Mockito tests. And then in the data module, I believe you can use Roboelectric, I think. And then for the presentation module, you can use Espresso, etc. to do your testing. So it gives you kind of the advantage that you can have separate testing for each module and not getting them mixed up. This approach also gives us the advantage when we're working with a team that has, let's say, kind of a specialty. So if you have people that are mostly focused on the UI, they can kind of get involved with the presentation module and focus on that and not getting mixed up with the rest of the modules when a lot of people are working into one project. And then if you have people that are more into backend, they can work with the data module. Next, we have an approach with Kotlin, where here it's a different. It's not actually for me personally. It's not language. It shouldn't be architecture. Shouldn't be language based, but some languages gives us some extra benefits. So to work with specific approaches. So in this approach, everything is within one module. We have one module, the app module, and we have they have applied the MVVM approach, and also they have structured it, as you can see here, into packages, a lot of packages, splitting it into the core packets and into the features packets. So this approach, it's more feature-based. And so in the core packets, you will find stuff such as frameworks, framework abstractions, dependency injections, and any global functionality that the whole application utilizes. And then in the features packets, there you will find the different features in the different packages. And each of that feature will contain the domain, the data, and the presentation related classes that we talked about before. And also I will, the example that I will show with the flow of the code will be this one in Kotlin, but we'll see that in a bit. Next we have iOS. So for iOS, there is this approach, the clean Swift approach that exists out there for clean architecture, which is called Clean Swift. And they use the VIP approach, which is view controller, interactor, presenter. And so the view controller is used as a glue between the interactor and the presenter. The interactor is actually the use cases and where the business logic is. So as you can see here, this approach, the people that they have done an example with this approach have also created a template that you can put on your Xcode and automatically create all the layers and the classes that you need. And I have also put the link for that at the end. So here we have our business, let's say, groups where we have our models and our interactors where all the business logic is there. And then we have our workers where our workers have to do with handling the data. So there you will find all the networking responsible to retrieve the data and all the data handling. And then we have our presentation where you will find the presenters and the view, etc. And then there's another similar approach with Swift UI, where it doesn't use the VIP approach, it uses the MVVM approach. And the project is kind of structured like as you can see here. And in the business layer, you can find the view model, the services, the application state. And one thing I would like to mention in the previous one is that they use a router to do the whole coordination of things, whereas here they play mostly with Swift UI components with their state of the components. And then we have the data layer where there you can find the repository, and then the presentation where you can find the view of your project. Now, let me let me show you. So I hope you can see my screen still. Here is an example. It's by Fernando Cejas. I hope I'm not butchering his name. And this is the Kotlin approach with the model Vivi model. And he has split the project into packages. So we have the core package and the features package. And as you can see here, in the core package, he has classes that are kind of global. So we have a class use case, or we have base activity, base fragment, anything that can be used multiple times throughout the application kind of goes there. So here, let me open up, the features. We have login and movies, okay. So if we open up movies, we can see that we have both our domain logic and our data logic and our presentation logic all in one package. So let me start with the fragment. Here we have the movies fragment, and in the onCreate method, they actually subscribe to the view model. So as you can see here, we have movies view model, which is subscribed here, and it actually observes the movies list, and then the view model executes the use case. As we can see here, get movies is our use case, and it executes it. And then, of course, if it's a success, it returns to the fragment using the live data, because Kotlin has live data, and it utilizes that to update the UI through the movies fragment, and then the movies fragment renders the movies list using the movie view. So let's go one step backwards. So the view model, the movies view model executes the use case, which is the get movies use case, as we can see here. It has a dependency there. And then the use case get movies actually is executed, is actually called from the movie service, where the movie service, it's an implementation of the movies repository, as we saw in the beginning, the repository pattern, where we have a movies repository interface, which actually is being placed in the domain layer. And then the movie service implements that interface. So it's kind of the glue between them to create a bridge between those layers through this interface. And of course, we have movie, which is our domain class, our base class. Okay, so this is an example of how the flow goes with the code and how the dependencies goes between those layers. I don't know if I made that clear. Another thing, a last thing I would like to talk about is that when clean architecture is actually not ideal. So it's, of course, you can use it in any project that you would like, but in my opinion, if you have a small project or a disposable app that you create once and then kind of throw away, it's not very ideal to create all these layers and all this big structure for one disposable app. Also, I don't know if this exists, but if you have non-changeable requirements that don't really change, also this is an architecture that's not very ideal. This architecture, it's mostly for teams that are constantly on the move and always adding new features. So that's why also the approach with the Kotlin, which is feature-based, can also be applied to teams that work on specific features. So you have multiple teams that they can work kind of in parallel and create the different packages each team. And also, if you can't afford to maintain all those layers, you don't have the resources, you don't have the people, also it's not an ideal architecture. And if you already have an app already implemented, the transitioning to this architecture may be costly in the beginning. So yeah, these are kind of the reasons that you might want to think before choosing to actually apply this architecture. And so here are all the resources that I've used to create this presentation. I know that I have put a Pluralsight a video, but for the month of April, it's free, so you can go ahead and take a look at it. And right now, it's a great video, and all the repositories that I used the examples from. So yeah, I don't know if you have any questions, and if anyone has actually used clean architecture and has any tips, you're more than welcome to share them with us. So yeah. I can't really see what you're writing right now. Mackenzie, you there?
Yeah, I'm here. So
Okay,
I don't think that there's any immediate questions.
Okay, great.
Yeah, everyone's just saying like thank you and giving praise, and that was a great presentation. So thanks so much, Vivian. And also, like Vivian said here, I'll post the link to our Slack again. I think I got it.
Yes, and if anyone has any questions at all or wants to talk about clean architecture a bit more, you can reach out to me on Women Who Code Slack channel, and we can definitely chat there.